Altogether, there are many of them, and understanding the origin of them would have helped us figure out the nature of the object, but they ignored them.
The moment the JUICE spacecraft broke protocol, alarms were already ringing, not on speakers, but in the minds of the engineers watching the telemetry scroll by. A navigation camera, never designed to study comets, was being pushed beyond its purpose. There was no time to reconfigure scientific instruments. Whatever was happening out there was happening now. What came back was barely an image at all, just a quarter frame, compressed, delayed, and dragged through a slow antenna link. But the instant it resolved, the room went quiet. 3I Atlas was not dim. It was not fading. It was active. Violently so. At the center of the frame, the nucleus burned brighter than models predicted, wrapped in a dense glowing coma that should not exist at this distance from the sun. This was not residual heat. This was sustained output. The kind that suggests internal processes still accelerating after perihelion, not calming down. Above it, a plasma tail cut sharply through space, rigid and bright, twisted by the solar wind in real time. Its shape showed active ionization, charged particles being stripped and redirected with force. This was not a passive object drifting through sunlight, it was reacting. Then scientists noticed what sat beneath it. A second tail, dust-based, faint, almost easy to miss, drifted at a wrong angle. Not aligned with gravity, not aligned with radiation pressure. Its motion refused to obey familiar rules. Analysts zoomed in, recalculated, and froze. The dust grains were the problem. Their size distribution didn't match anything seen in solar system comets, too coarse in some regions, too fine in others. As if the material wasn't breaking apart the way comet dust should, as if it wasn't made the same way. Within minutes, internal flags were raised. This was not just ice sublimating under sunlight. The response pattern suggested unfamiliar chemistry, materials interacting with solar radiation in ways models could not cleanly explain. Something inside 3I Atlas was being activated, not merely warmed. The timing made the discovery worse. This snapshot was captured just days after perihelion, the moment when solar stress peaks, when hidden layers crack open, when buried material is suddenly exposed. If something unusual was going to reveal itself, this was the window. And yet, this was all anyone was allowed to see. JUICE's full scientific instruments had already recorded far more detailed data, spectra, particle readings, dynamic measurements, but those files were sealed on board. They will not be transmitted back to Earth until 2026. Until then, humanity has only this fragment, a teaser, a warning. Right now, the most important phase of an interstellar object's behavior is unfolding without witnesses. And what comes next, what else that locked data contains, may explain why 3I Atlas didn't just survive its encounter with the sun, but seemed to wake up after it. And that realization sets the stage for what the chemistry reveals next. The danger was no longer visual, it was chemical. And it was unfolding faster than expected. As JUICE sped past from 41 million miles away, instruments began flagging data that made scientists stop mid-analysis. The comet was emitting gases that should never dominate together. Carbon dioxide levels surged far above water vapor, an inversion that defies how comets normally wake up under solar heat. In known physics, water ice leads the reaction. Here, it was being overshadowed. That single ratio was enough to trigger internal alerts. Something inside 3I Atlas was responding to the sun in a way no local comet ever has. Then the elemental readings arrived and the situation worsened. Gas spectra showed nickel rising sharply while iron lagged behind. That imbalance made no sense. In the solar system, these metals travel together, forged under similar conditions. But this object was different. Nickel-rich. iron poor. The signature pointed to an environment colder, harsher, and possibly far older than anything that formed near our sun. Scientists quietly acknowledged the implication. This material may have condensed around a star system unlike our own, or before our solar system even existed. The alarm deepened as multiple instruments confirmed the pattern. This was not noise. This was not a calibration error. Independent sensors agreed. Even the dust grains themselves behaved strangely, absorbing and releasing heat in unexpected ways, reacting faster than models predicted. Solar radiation wasn't just warming the comet, it was unlocking something unfamiliar inside it. Every hour of exposure made the chemistry more pronounced, not less. With each new data packet, the conclusion became harder to avoid. 3I Atlas is not just visiting from another star. It is built from rules that don't fully apply here. And as it continues to heat up, scientists are no longer sure what reactions will trigger next, because chemistry like this doesn't stabilize. It escalates, and the next set of observations is already hinting that motion, not composition, may be the real warning sign waiting to surface. Hubble's second look did not calm fears, it sharpened them. On November 30th, the telescope locked onto 3I Atlas with surgical precision, tracking the comet while the background stars smeared into long, violent streaks. This was not a visual artifact, it was raw proof of speed. The comet was tearing through the inner solar system faster than models had prepared scientists for, fast enough to turn the universe behind it into motion blur. At the center of the frame, something worse appeared. Hubble confirmed a bright, compact core still burning with activity months after discovery, long past the point where most comets begin to fade. Around it clung a dense dust cocoon, tightly bound, sharply defined, and unmistakably alive. This object was not cooling. It was not settling. It was still reacting. That persistence triggered immediate concern. Interstellar comets are expected to lose energy quickly once solar heating peaks. Their volatile layers should exhaust fast. But 3I Atlas refused to follow that rule. Its activity did not decay. It sustained. The dust structure retained a teardrop shape, a signature of continuous outgassing, not residual debris drifting away. Scientists noted that the dust was being actively replenished. That meant something inside the comet was still being driven hard by the sun, far harder than predicted. Solar energy was not just warming surface ice. It was triggering deeper responses, unlocking material that should not have been exposed at this stage of the pass. Every new frame reinforced the same unsettling conclusion. This was not a passive visitor gliding through space. It was interacting, responding, adjusting. The comet's internal composition was actively reacting to solar radiation, as if its structure was tuned differently, built for conditions no one had modeled before. And the speed made it worse. The faster it moved, the more intense the stress. The more intense the stress, the more violently the comet responded. Models struggled to keep up. Assumptions began to crack. If the object was still this active now, scientists had to ask a dangerous question. What happens as the reaction escalates? Because if this behavior continued or intensified, then Hubble had not captured the peak. It had caught the acceleration phase, and whatever comes next would not arrive quietly. The shock did not come from what 3I Atlas was doing, but from how old it might be. When trajectory analysts finalized its incoming speed and angle, the room fell silent. The numbers did not match objects born alongside the sun. This comet was moving too fast, arriving from a direction too clean, too detached from known stellar nurseries. The math pointed to a terrifying possibility. 3I Atlas may have formed before the solar system itself existed. Not older than Earth, older than the Sun, older than the planets. A survivor from a time when the galaxy was still chemically young and violently unstable. That realization changed everything. If the comet truly predates the solar system, then its interior is not recycled material. It is pristine cosmic memory. Chemistry, frozen billions of years ago, sealed before planets learned how to form. NASA scientists quietly admitted the implications were unsettling. Ancient matter, untouched since the early galaxy, is now being slammed by modern solar radiation and reacting aggressively. Jets are firing. Dust is deforming. Gas is erupting in ratios that do not belong to anything nearby. This is not passive sublimation. This looks like awakening. Astronomy almost never witnesses primordial material under direct stress because objects this old usually never come this close to a star again. Every flare from 3I Atlas may be exposing chemical structures humanity has never measured before. Every outburst could be stripping away layers that have survived since before Earth had an atmosphere, and that is where the fear sharpens. Once the comet escapes the sun's grip, that record vanishes forever. There will be no second pass. No retrieval mission, no correction. What is lost in this flyby is lost to the galaxy itself. Scientists now realize they are watching a one-time experiment unfold in real time, and they are already behind. Because while the age implication alone rattled the room, it raised a far more urgent question. If this object is that old, what exactly is locked inside it? The danger is no longer in what scientists have seen, it is in what they cannot access. 5 of JUICE's most sensitive scientific instruments were aimed directly at 3I Atlas during the November flyby, gathering data at a level never achieved for an interstellar object. Spectrometers, particle analyzers, and plasma sensors recorded the comet's behavior as it reacted violently to the sun. This was not a casual scan. It was a full diagnostic sweep of an object already behaving outside known physics. Those instruments captured far more than the blurry quarter-frame image released to the public. They recorded how gases erupted, how dust responded to solar wind, and how charged particles wrapped around the nucleus. Every second of that pass added layers of detail to a dataset that could redefine comet science. And then the transmission window closed. The problem is timing. All of that high-resolution data is sealed inside JUICE's onboard memory until February 2026. No emergency download, no early preview, no second look. Scientists already fear what may be hiding inside those files. The teaser image alone shows signs of peak excitation, a state where internal chemistry reacts aggressively to solar stress. That usually fades quickly in known comets, but 3I Atlas did not calm down. If the sealed data confirms intensified outgassing, unstable molecular ratios, or exotic particle behavior, it would fracture existing comet models. Interstellar objects are not supposed to remain this active for this long. They are not supposed to reveal chemistry this volatile after perihelion. And they are definitely not supposed to challenge how planetary systems are thought to form. Right now, the most complete portrait of an interstellar visitor ever recorded is physically unreachable, locked in a spacecraft millions of miles away. The weight itself has become part of the experiment. Every month that passes increases the stakes because no one knows whether the data will explain the anomaly or expose something far stranger. And as scientists wait for 2026 to arrive, a more unsettling question hangs in the background. What if the comet's most important behavior happened during those unseen moments and we only realize it after it's already gone? The countdown has already begun. Despite calm language in official briefings, scientists feel the pressure tightening by the week. 3I Atlas is no longer just an object under observation. It is an object in retreat. Every new calculation confirms the same unsettling fact. The comet is accelerating away from the sun faster than expected, its trajectory hardening into an irreversible escape path. This is not normal behavior. As it pulls away, the comet remains chemically unstable. Instruments continue to detect reactions that should have faded after perihelion, yet 3Y Atlas refuses to quiet down. Gas production persists. Dust structures remain distorted. Ionized material still responds aggressively to solar wind, even as solar energy weakens with distance. In 2026, the comet will cross Jupiter's orbit. That moment marks the end. Once it passes that boundary, gravity will no longer offer meaningful interference. No planet will redirect it. No spacecraft will catch up. No late mission can be approved, launched, and intercepted in time. The solar system will lose access to the object forever. Scientists are painfully aware of what that means. Every observation happening now is the last observation humanity will ever make of this body. Every spectrum, every image, every chemical ratio is a one-time event. There will be no follow-up pass, no correction of mistakes, no chance to ask new questions once better theories exist. And yet the comet continues to misbehave. Instead of stabilizing as it exits, 3I Atlas keeps revealing contradictions. Its chemistry remains out of balance. Its dust refuses to disperse predictably. Its reaction to decreasing solar radiation does not align with existing models of comet aging or exhaustion. Each data point raises more questions than it answers. This is not a threat in the traditional sense. There is no collision risk, no danger to Earth, no emergency response underway. But among scientists, a different kind of alarm is sounding. This is a knowledge deadline. An object that may predate the sun itself is undergoing its final interaction with a star, and that interaction is exposing internal chemistry no one expected to see. Ancient material, possibly billions of years older than Earth, is reacting under stress for the first and last time while instruments struggle to keep up. The comet is not waiting. As it accelerates outward, the window narrows, signals weaken, resolution drops, solar influence fades, potentially shutting down the very reaction scientists are desperate to understand. What is visible now may disappear without warning. And somewhere inside sealed datasets and incomplete models lies the answer to a question no one is ready to ask out loud yet. What exactly are we watching leave, just as it finally started to reveal itself? The next phase begins not with a discovery, but with what scientists fear might already be slipping beyond reach.